Hi all. See this. This is a problem which came in the year 2019 main paper. It talks about that we are having a matrix A regarding cos alpha, sin alpha and all that. That's okay. But we need to find A32, like A to the power 32. And obviously you'll see that it's impossible to find A to the power 32, right? We cannot multiply A32 number of times, right? Or maybe close to that, right? Because if I calculate A square, again we can get A to the power of 8, 4 and all that. But that's a ridiculous job, right? So to solve similar kind of problem, our job is to find the pattern, right? So that we can guess that A32 or A to the power n, A to the power 85 or whatever, right? So that's why first we need to go ahead and multiply few times, like get A square, and let's see that can we observe some pattern, right? So that's actually our job. So here A is there, so let us first try to calculate what is A square, right? So let's calculate the A square term first. So A square gives me that 2 times of A multiplication. So see that cos alpha minus sin alpha, then sin and cos. We multiply with the same matrix. So therefore cos alpha minus sin alpha, then sin alpha and cos alpha. Let's go ahead and multiply. So therefore, we'll see that we'll get it as cos square alpha plus minus sin square alpha. So write cos square alpha minus sin square alpha. Then we can have minus sin alpha cos alpha. Then we have minus sin alpha cos alpha. That's it. If I multiply again, we get sin cos plus sin alpha cos alpha. Here we'll get cos square alpha minus sin square alpha. So what we'll get? Using the formula, we'll say that this is cos 2 alpha minus sin 2 alpha, then sin 2 alpha and cos 2 alpha. So now we are able to calculate what is actually that A square, right? Why so? See that cos square minus sin square alpha equal to cos 2 alpha, but this is minus 2 sin alpha cos alpha, that gives you as minus sin alpha cos alpha. So 2 sin alpha cos alpha and so on. See that it's need to be written little closer, otherwise it looks like cos 2 alpha minus sin 2 alpha. Okay, that's it. So we get A square, right? From A square also we can predict that. What is the prediction? You can see that here we can see that cos alpha A is A to the power 1 cos alpha. A square is equal to cos 2 alpha. But maybe it's changed for A cube. We don't know. So let's try that A cube as well. Okay. So what is A cube? Let's try to multiply that now. So we'll say that A cube is equal to obviously A into A square or A square into that, whatever way you choose. So therefore you'll multiply cos alpha minus sin alpha, sin and cos, multiplied by cos 2 alpha. So let's go ahead, cos 2 alpha sin 2 alpha minus sin 2 alpha cos 2 alpha. That's it. Let's go ahead and multiply it now. So let's see that. So we'll have cos alpha cos 2 alpha then we have cos alpha cos 2 alpha and plus sin alpha minus sin alpha sin 2 alpha. That's it. Go ahead for the next term. So therefore we'll get it as cos alpha sin 2 alpha minus sin minus, so we'll get it as minus of sin alpha cos 2 alpha. So that's it. So obviously we are able to get the first row. Now we have to multiply it by second. So sin alpha into cos 2 alpha. So we'll write it as sin alpha cos 2 alpha plus cos alpha and sine 2 alpha. And here we have the same thing. We'll have that cos alpha, cos 2 alpha minus sine alpha, sine 2 alpha. So just a matrix multiplication. So it gives you that, see that this is a formula of cos A cos B minus sin A sin B. That means cos A plus B. That means cos 3 alpha. So cos 3 alpha. This is minus sine 3 alpha. Again we have sine 3 alpha and cos 3 alpha. So now see that whatever we're going to predict at the step 2, we can use the same logic here, right? So therefore we'll see that whatever the power we are need to read the same value again here. So therefore you can see that therefore my prediction is that A32 will gives me that cos 32 alpha minus sine 32 alpha, sine 32 alpha, cos 32 alpha. That's it. Now it is given that this matrix is equal to 0, minus 1, 1, 0. So let's write down here itself. So it's given that A32 it's equal to 0, minus 1, 1, 0. So therefore by comparing we can see that so cos 32 alpha is equal to 0 and sine 32 alpha is equal to 1. Now see that we can easily say that by this thing that the angle is lies definitely in that first quadrant, not that first quadrant but obviously in that zone, right? Because here sine is positive and cos is also positive. So sine and cos both positive, right, in the first quadrant itself. So therefore we'll say that in this case my 32 alpha is equal to pi by 2. That's imply that alpha is equal to pi by 64, and that's why here the required option is obviously option C, and that's 64. Now see that I mentioned one thing that here that angle alpha is in first quadrant. Obviously not that first quadrant, because first quadrant means that your angle lies between 0 to pi by 2, not that pi by 2 included, right? But we can think of that based on our, because this 0 to pi by 2 can be represented in the triangle form and all that, so we obviously know that, okay? So that's it. Hope you understood the technique and the problem. Thank you.